Okay, 6-4. All right, so we're gonna do the last two groups of identities. You need your formula sheet for these ones. They are very similar to one another. You're gonna notice. All right. All right, we're going to start here. Product to sum identities. All right, so product to sum identities are on the bottom right side of your sheet. You'll see product to sum and sum to product are the two that you're looking for. They are exactly what they sound like. We use product to sum identities to change a product into a sum or difference. Okay, so the first one we're going to do is cosine 3x, cosine x. So we're going to take cosine 3x, cosine x, and we're going to write it as a sum or a difference. So a product, things are multiplied into a sum or a difference. When you use these formulas, you first want to focus on what functions you have that are being multiplied together. So here they're both cosines. So I'll be using the identity at the top, cosine times cosine. And anywhere I see an x in the formula, I'm going to plug in my first angle, which here is a 3x. And anywhere I see a y in the formula, I'm going to plug in my second angle, which is just x. So x just means first angle, y just means second angle, okay? So here's what it's going to look like. 1/2 cosine, and then x minus y. So subtract your angles in the order they're given. So in this problem, that would be 3x minus x. Plus cosine, and then add your angles together. 3x plus x. And then all you do is simplify as much as you can. So 3x minus x gives me 2x. 3x plus x gives me 4x. And then we distribute the 1/2 through. So it's going to be cosine 2x over 2 plus cosine 4x over 2. And the instructions are to write it as a sum or a difference of two fractions, which is what I have. So I don't want to add them together, even though you could. They have a common denominator. You also can't reduce anything here because that 2x and 4x on top are in the angle. They're not outside the function, so nothing simplifies. And then this is your answer. Okay? All right, let's do the one at the bottom. I have to find the exact value of sine 15 cosine 75. So sine 15 and cosine 75 are not on our unit circle. And if I want to find an exact value, one way to do that is I can use the product to sum identities. If you turn it into the sum of two different angles, you could hopefully get angles that are on your unit circle and evaluate each of those separately. Okay, so this one is a sine times a cosine. So I'm going to use the other one on top up there, or you can find it on your sheet. So it's going to be 1/2 sine, add my angles together, 15 plus 75. Do not change the order of them, 15 first, 75 second, and then plus sine, subtract. Okay? And then we simplify. 15 plus 75 gives me 90. 15 minus 75 gives me negative 60. Now, yesterday we talked about if you had a negative angle, you could get rid of that negative using what group of identities on your sheet? Even, odd. So is sine even or odd? It's odd. If you have a negative, you can bring it out front of the function. Okay, so it's going to be 1/2 sine 90 minus sine 60. And now you can evaluate with your unit circle. What's the sine of 90? 1. Sine of 60? We're at 3 over 2. distribute my 1/2 in. I'm going to have 1/2 minus rad 3 over 4. And then get a common denominator. What's my common denominator? Common denominator is 4. So instead of a 1/2, I can think of it as 2/4 out front there. So it's going to end up being 2 minus rad 3 over 4 is your final answer. And ones like this where you can evaluate completely, you can check with your calculator like the other ones. You can type the original problem in, type the answer in, make sure the decimals match. Okay? Questions on product to sum. That's all we're going to do with those ones. Cool. All right, the other group is the sum to product identities. These ones are used more often because it is more beneficial to turn something into a product, usually, because if something is a product, we can cancel, reduce, especially if we have fractions. So we use these guys a little bit more. But again, they're exactly what they sound like. We're going to take things that are added or subtracted and turn it into things that are multiplied. Okay, and whatever's first in your equation or your expression is the x, whatever's second is the y. So first one, I have cosine 2x, cosine 4x. So I have a cosine minus a cosine. So I am using the second one on the left there. Cosine x minus, bless you, minus cosine y. All right. So this one starts with -2 sine. And then inside these angles, you're either adding or subtracting and dividing by 2. So this says x plus y divided by 2. So that just means take my two angles that I have, add them up, divide by 2. So 2x plus 4x over 2. And then sine again. And then subtract them. 2x minus 4x over 2. And then we simplify as much as we can. So 2x plus 4x over 2. What does that give me? Well, 2x plus 4x gives you 6x. Divided by 2 is 3x. And then sine 2x minus 4x gives me -2x. Divided by 2 is -x. The only other thing you can simplify is you have a negative angle. Again, the negative is in a sine. And because sine is odd, according to those even odd identities, you can bring it out front. Now, I could bring it out front of just the sine function, but this is all multiplied together. It's all just one big term. So I'm just going to bring it out front of the whole term there. So if I bring it out front, there's already a negative there. It just cancels. You're going to get 2 sine 3x sine positive x. Final answer. All right, with your partner or somebody near you, try the bottom one. Evaluate as much as you can. Simplify as much as possible using the sum to product identities. Cosine 13. Final answer. That's as far as you can go with it. Sine 30 is a half. Correct. Okay. Any questions on those? All right. Got 3 more problems. That's it. Okay. Next one, we're just going to do the one at the top here. Let's say you want to write sine 2x cosine x as a product. Okay, so we're going to change a sum to a product, which means you are going to use sum to product. Now here's where we have an issue. Sum to product identities only have, if you look at all the formulas on your sheet, 2 of the same function added or subtracted together. So they're either both sines or both cosines when you look at sum to product. So we have to change one of these. We have to either change the sine to a cosine or the cosine to a sine to be able to add or subtract them together and change it into a product. Now here, we're not proving anything. It's not an identity. So we don't actually care if our angle stays the same or not. Usually we do care about that because we want everything to remain the same in our proofs. But here we don't. So we're going to use the cofunction identity. to change a sine to a cosine or a cosine to a sine. So, and you can change either one, it doesn't matter. Let's say I want to change cosine x into a sine function according to the cofunction identities, and we did those back in chapter 5. We haven't used them a lot. Cosine x is the same as sine of 90 minus x. Okay. Now I have two sines that are added together, so I can use the sine x plus sine y identity. And everywhere you see x, you're going to put 2x in its place. Everywhere you see y, you're going to put 90 minus x in its place. All right, so that one looks like 2, and then sine, and then we're going to add up our angles and divide by 2. So 2x plus 90 minus x over 2. And then it's a cosine, and then we're going to subtract our angles and divide by 2. Now you have to be careful when you subtract because 90 minus x is a quantity. So I would maybe put it in parentheses. It's kind of like an intermediate step here. Over 2, like that. Okay. And then you just simplify as much as you can. So for that first parentheses, I could make it 2x minus x just gives me x plus 90 over 2. And then for the second parentheses, imagine you're going to have to distribute that negative in. So I really am going to have 2x plus x when I distribute the negative in, and that's going to give me 3x minus 90 over 2. And then my fractions actually here don't reduce any further than that. So final answer. That's it. Okay. If you had something like cosine 3 theta and you wanted to turn that into a sine, it would just look like sine of 90 minus 3 theta. If you use those cofunction identities, it's just 90 minus whatever angle you have. Okay, so that doesn't change. Questions on that? If you have two different functions, what you do? All right, so last two problems today are two proofs, of course. And that'll be it for 6-4. All right, so I am verifying cosine 5x minus cosine x over sine x minus sine 5x is equal to tangent 3x. So we use these identities to prove often when we have a sum or a difference, things that are added or subtracted, and we want it to be a product. And if I have a fraction, if I turn everything into a product, I'm going to be able to cancel stuff. Remember, we have to have a common product or a common factor to be able to cancel things. So we're going to use the sum to product identities twice. We're going to do it in the numerator and in the denominator and just kind of see where the chips lie from there. Okay, so in the numerator, I have cosine minus cosine. So that's the one you're looking at on your sheet. Cosine x minus cosine y. So that's the one that has a -2 in front of it. Sine, and then we're going to add our angles and divide by 2. Keep the angles in the order they're given. So 5x plus x over 2, and then it's sine again, and then subtract your angles. Divide by 2. Okay. The bottom I have sine minus sine, so that's the very last one on your sheet. 2 sine, subtract my angles, divide by 2, keep them in the order they're given. So it's going to be x minus 5x over 2. And then cosine x plus 5x over 2. Now we simplify. In the numerator, I have 5x plus x over 2. So what does that become? 3x. And then I have 5x minus x over 2, which is 2x. Okay. In the denominator, I have 2 sine x minus 5x over 2. What's that? Bless you. -2x. And then cosine 3x. Okay, anything else we could simplify here? Yeah, negative angle, and again, it's a sine, so what can I do with that negative? Get rid of it or move it out front? Move it out front. If I take that and move it out front, here's what I have. Negative 2 sine 3x, sine 2x on top. That stays the same. Negative 2 sine 2x, cosine 3x on the bottom. What cancels now? It's all products, all multiplied, right? So
negative 2 sine x, the sine 2x.
And the sine 2x's. So then you're left with sine 3x over cosine 3x in the same angle. So if you ever have sine over cosine, as long as it's the same angle, you can write it as tangent of 3x. And that's our answer. Okay? Questions on that one? All right, the last one is going to be for you guys to try, and then this is it for the day. I want you to start this one the same way as the last one, okay? So I want you to turn the top into a product and the bottom into a product and see what you can simplify in that fraction. I'll give you a couple minutes. I'll pass out your packets maybe while we're doing that. All right, I have a feeling that you maybe got this far or close to it. Okay, so you're close here because on both sides you have a cotangent x plus y. Addition order doesn't matter. So cotangent x plus y is the same as cotangent y plus x. We're good. But subtraction order does matter. So this x minus y is different than that y minus x. There's also this extra negative out front here. Okay, so the last step is you're going to use your even odd identities. Now, the only two functions that are even, where the negative just disappears, is cosine and secant. Now, I have cotangents. Cotangents are ones where if I have a negative angle, I could bring it out front. And usually that's how we use it. If we have a negative, we bring it out front. We're going to do the opposite here. I have a negative. I'm also allowed to distribute it in to any term I want to. Okay, so we're going to distribute it into this angle on that cotangent. And what that's going to do is it's going to get rid of that negative out front, and it's going to flip the signs that I have. So I'm going to have a cotangent x plus y, which I can write y plus x now. And cotangent, when I distribute the negative into the angle, it'll be a positive y and a negative x, which is what you have on the other side there. Okay, so a little tricky at the end. Hopefully you at least got that for with the product to sum identities getting down there, okay? That is it for 6-4. So here's what's happening the next week. Next week we are learning no new material. We're just like practicing what we know, showing what we know, all that stuff. So 6-4 packet that you just got. First of all, cross out the last problem, number 72 on it. You do not have to do it, okay? And the whole back side's blank. Let's not even call it a packet. Let's just call it a worksheet that I spread out, okay? It's not that much. Remember, both of your homeworks are due on Wednesday next week, okay? So cross off number 72. You don't do that one. All right, so next week, the circuit training that you guys have had for a while is due on Monday if you're doing that. We're going to play maybe a couple games with Quizlet, look at just to practice your trig identities, getting ready for that memorization test. We won't do that all period, so you'll probably have some work time on Monday as well to work on your homework. On Tuesday, you have another open note partner quiz just over these last two sections that we did, the sum to product and the double angle, half angle stuff. On Wednesday, you're going to turn in your homework and we'll do the memorization test. I already put the Quizlet link on Polaris for you, so if you want to start using that, you can. I'll tell you those sum to product, product to sum ones, those are the toughest ones on them, but the rest of them, as you guys use them at the proofs, you'll get a little bit better with those. Thursday, we'll review together for the first part of the test, and then Friday, we'll take the first part of the test. For that part on Friday, remember, you are going to get all the formulas. I'm going to give you the formulas. I'm going to give you a blank unit circle. That's where you're just going to have to use them. You won't have to have anything memorized for that day. Okay, so a little bit at a time, but nothing new next week. Just kind of taking what we have and using it. Yeah?
What is the, aside from just getting this sheet and fill it out, what is the format of the memorization test?
That's pretty much it. So, no, it's not completely blank. So I'll take, the groups of identities will be in this order. Now the ones like within each group might be scrambled a little bit from what you see on this worksheet, but like the first thing you'll see on there is reciprocal identities. And then there'll be 6 blanks below that. I'm gonna give you the easy side of the equation, and you're gonna fill out the tougher side of the equation. So like for reciprocal identities, there'll be 6 blanks, and it'll say like cosecant equals, and you're gonna put 1 over sine next to it. Sine equals, you're gonna put 1 over cosecant. So for every one of these, it'll be labeled with the name of the identity, and I'm gonna give you the easy side, and you're gonna fill out the hard side.
The longer side.
The longer side, yeah.
Alright.
So what fun is that if you fill out the easy side?
It'd be pretty fun for me.
What fun is that for me? All right, and then for like these ones where you have multiple ones, double angle and a half angle for cosine and tangent, you do need to fill all 3 of them. There'll be 3 blanks there. Okay. Yes. Okay. Literally, these are the answers. It's right in front of you. Easy test points. Just gotta study a little bit. Okay. Just make a little study group, quiz each other, we'll practice some on Monday together. It'll be great. It'll be great. All right, I'll do cell phone lotto. For us to furious yours, guys.
I keep thinking like that.